Hi there, grade 12s. On this lesson, we're going to look at your trial exam preparation. So I'm going to look at question 5. I'll only do question 5. I just want to show you how to answer some of the questions on question 5, trigonometry. So if you look at this 5.1, this is like 8 marks, and you are given an if statement, and they want you to express the following in terms of t, meaning your answer should have t. So we are given the sign. This is what you are given. Uh, okay, so we have the sign of 19 degrees, and this is t. So remember, I'm gonna put the SOHCAHTOA on top. Okay, so what is going on is that uh, from sine is opposite all over hypotenuse. So this is over 1, opposite that's y, hypotenuse that r. So we know that your y, that's t, and your r is 1. Then you're going to draw a right angle triangle. So I'm just going to put my right angle triangle somewhere up here. So this is the right angle triangle that we need to use to answer the question. So now remember, if this is a right angle triangle, we have this as 90, and I'm gonna look at the given angle. This is 19. You're going to write your 19 somewhere here. Okay, so this will be 19 degrees. Okay, perfect. So if I have 90 and I have 19 inside the triangle, so what is this telling you about the third angle? We can see that the third angle, if you say 90 on your calculator, you're gonna take your 90 degrees, you subtract, you're gonna take your 180, you subtract 90 and 19, this gives us 71. So this angle is 71 degrees. So now what you're going to do on your right angle triangle, remember, you know what is your opposite, right? Is t. So this side is t, and your adjacent, that is something that we need to look for. This is your x, we need to look for that x, and your hypotenuse, that's 1. So before you answer any questions, make sure that you use theorem of Pythagoras to find the missing side, which is x. We need to use theorem of Pythagoras to find that side. So let me quickly work on that. So r squared is equal to x squared plus y squared. So my r, that's 1 squared. Okay. So this is 1 squared. It's equals to x, it's what we are looking for. Then I'm gonna say y, which is t squared. So now let's make x subject of the formula. X is just the root of, because this will be 1 minus t squared, but we need to square both sides, right? So now I'm going to say this will be like plus or minus, guys, but when you look at this Cartesian plane, this is in quadrant 1. 19 degrees it's in quadrant 1. If this is my Cartesian plane, this angle here is in quadrant 1, so x is positive. So I'm just going to leave it as positive. I hope you guys understand that part, because let me quickly indicate how this will look like. So this will look like this. This is your 19 degrees. This is quadrant 1. That's why the value of x should be positive. If you are happy about that, let me quickly answer the first question. The first question is asking, what is the cos of 19? Okay, so to answer the first question where they want the cos of 19, you just have to use this, because we know that cos 19, we're gonna use that triangle because there's 19 degrees there. Then what you're going to do, you're gonna say cos its adjacent, you write down your adjacent, which is the root of 1 minus t squared. Remember, this is your adjacent, this is your opposite, and this will be your hypotenuse. Okay, so this is adjacent over 1, adjacent all over hypotenuse, which is 1. Then you can just say your final answer is the root of 1 minus t squared. So that is the cos 19. Then you've answered 5.1.1. You move to 5.1.2. They are asking for the sine 38. Look at this. Inside this right angle triangle, do we have 38? No. You need to make sure that you only work with 71 or 19 degrees. How can we make 38 to be 19 degrees or 71 degrees? The best way to do this is to say this will be the sine of, then we know that 2 times 19 gives us 38. So I'm going to write this as 2 into 19 degrees. So I'm going to break the 38 into 2 times 19. Right. So I think now you can see that this is the same as saying this is the sine of 2x. What's your x? 19. And if this is a double angle for sine, we can write this as 2 sine x, the cos x. So meaning that this can definitely be written in this 2 the sine of your x, which is 19. So this will be the sine of 19 degrees times the cos of 19 degrees. Okay, I'm not going to stress about the sine 19 and the cos 19 because already we know that sine 19 it was given as t. So this will be 2, where the sine 19 I'm going to put t multiplied by the cos 19. Cos 19 is what we calculated on 5.1.1, and we said this is the root of 1 minus t squared. So this guy here, that's your final answer for this should be your final answer for that 5.1.2. This is amazing, right? So when I have this, I'm just gonna move to the next 5.1.3, which will be the last question of 5.1. Okay, so now I need sine 101, and how can we work with this one? How can we work with this one? We need to make sure that we create one of these angles. So also try special angles. Can you break 101 into special angles? There's no way because of that one, but you can see that the one is coming from maybe 19 or maybe that's 71. So try to check, is there any special angle that I can add with to get 70? I can add with 71 or 19, and that special angle is 30. So when you break that, you can definitely break the 101 and write it as the sine of 30 degrees plus 71 degrees, because special angle I can find sine 30, I can find the cos of 30, because this will be a double angle for sine. So when you go to your the formulas, you'll definitely find something like saying the sine of A plus B, it's equals to the sine A, the cos B, and then we add the cos A, the sine B. Okay, so this is the rule that I'm going to use. Like, I'm going to write this as the sine of 30 degrees times the cos 71 degrees. Then let's add the cos of 30 degrees sine 71 degrees. Okay, so now the good thing about this is that sine 31, I mean the sine of 30, it's half, so this will be half multiplied by the cos 71. We need to use the diagram. Cos is adjacent over hypotenuse. Okay, but please note that if we are using this angle, my opposite becomes this side. This will be my opposite, and this will be my adjacent. So we are saying that cos is adjacent, so that will be t over hypotenuse, which is 1. That will be t over 1 times, oh, we're going to add the cos 30, it's root 3 over 2. Then the sine 71. Remember, your opposite is that root 1 minus t squared over your hypotenuse, that's 1. I hope this makes sense. Okay, so to work on the last part, you can just multiply your numerators and work on this. So when I say multiplying your numerators, this tells you that on top, maybe we can just write it here, 1 times t, that's t over 2. We are adding this with what? We are adding this with the root 3 times the root of 1 minus t squared. Everything is divided by 2 times 1, that's 2. So can you see that I'm not sure if you've noted that the denominators are the same. We can write this as one fraction. Everything divided by 2. Then you're gonna add your numerators, t plus the root 3 times the root 1 minus t squared. And remember, when you are in an exam, you find something like this. Sometimes you'll feel like whatever that you are doing is wrong. No, you are on the right track. Né? Okay, so when you look at this, how we break the 101, there's another way to do this. This is something that I need you to try. Remember, let's say maybe I want to work with 19 degrees. I can break this and write it as the sine of, instead of 30 plus 71, I can say 60. Then you add 90. I think that can give you 71 degrees. Then it's also a compound formula, you work on it. Right, moving to the next one. Next question, they are asking you to simplify the following. How do we simplify this? Why is this question 8 mark? Let's start with the reduction formula. You ask yourself, where is 180 minus x? That's quadrant 2. How is tan in quadrant 2? Negative. So that will be negative the tan x. Remember, there's a mark for that. Already you have 1 mark. The cos, I see 90. That's a cofunction. Cos changes to sine. Where it's 90 minus theta, that's quadrant 1, because when I minus from 90, I'm going to 0. So that's quadrant 1. How is cos in quadrant 1? Positive. But this changes into what? The sine of that angle. And everything is divided by 225. Where is 225? That's like between 180 and 270. So the tan of 225, we're going to reduce this and say this is the tan of 180 degrees. What should we minus? Oh, we need to add. What should we add to 180 to get 225? 45 degrees. Perfect. Okay, so now when I do this, I'm just gonna say, where is tan plus theta? That's quadrant 3. How is tan in quadrant 3? Tan is positive, so this will change into the tan of 45 degrees. So I'm just gonna write it down here. And also, so far you have 3 marks. Okay, so there it is, a negative angle. So this is the best way to work on a negative angle. You can start by maybe at 360. When you add 360 there, you just see that the 360 will cancel, which leaves you with what? Sine x. Then this will be reduced to sine x. So now, when you look on top, this is what you have, the sine 2x, which we can write this as 2, the sine x, the cos x, and look at what we have here, the tan, which we can write as the sine x over cos x. So I think that's the best way to work around that one. Okay, so now this will be the sine x over the cos x. Okay, so let me just quickly, because I'm just trying to see how will this help me. Tan 45, that's 1. Can we just change everything there? Let's see what we get on this step. So I'm going to change the tan. I'll be left with negative sine x over the cos x. This is multiplied by the sine 2x, which is 2 sine x, the cos x. Remember, everything here is over 1. Then let's divide everything by that 1 times the sine x. So I need you to pay attention on this, guys. This and this cancels, and sine x will be multiplied with 2 sine x. So what is that giving you? In fact, let me just not multiply it yet, because I can see that if I say on top, I'm left with 2 sine x times sine x, because I see that sine x on the denominator, and I think you can agree with me that this guy and that guy will cancel. So there's no need for you to multiply the 2 there on top, so that you can easily see that the 2 will cancel, and this leaves us with the final answer of negative 2 sine x. And that's it for this one. That was easy 8 mark. But if we say this is 8 mark, how are the mark allocated? We set 1 mark for the negative term. The changing sign to x, there's 1 mark for that. Okay, no, for sine 2x or the reduction, there's a mark for that, mark for that. That's 8 marks for so far. For the fact that you know the identities, 1 mark for that, and also for changing this identity, there's another mark. So far you have 6 marks, and they'll give you for saying the tan of 45 is 1 mark for that. So far you have 7 marks, and the final mark will be for the answer. I hope this makes sense. So let's keep moving to the next one. On this one, they want us to find a general solution. Okay, so we can't just work with this question. Let's remove the fraction. I think you can agree with me when I say let's multiply both sides by what? By the 4. So I'm going to take the 4. I'm going to multiply that tan squared x plus 1 over 4. And then what you do on the left hand side, you do it on the right hand side. So the 4 will cancel. This leaves us with tan squared x plus 1, which is 4. So let me move the 1 this side to be negative. Therefore, this leaves me with tan squared x. It's equals to the 1 comes this side to be negative. This leaves me with 3. So can I square both sides? Yes, I can do that to get rid of square, because remember, if I have the tan squared x, this can be written as tan x everything squared. So when you square both sides, the 2 cancels, right? So this will leave me with the tan x is equal to plus or minus the root of 3. I hope you understand that part. Plus or minus the root of 3. I hope you understand that part. Perfect. So now you just have to go to your calculator to find your reference angle and see what you get as your reference angle. So when you say the tan inverse of that root 3 without those signs, because the signs, they just tell us which quadrants we need to work on. Okay, so yes, they just tell us which quadrant we need to work on. The tan inverse, this gives us our reference angle to be 60 degrees, right? And then now we're gonna look at where tan is positive, where tan is negative, and then you can just definitely work on that. That's not an issue. So I think I'm just gonna work with quadrant 1 and also quadrant 2 if I take for the tan being negative, you understand? So if I take for tan being negative, that's quadrant, oh, I mean for positive, that's quadrant 1 and 2. So in quadrant 1, the solution will be you take your reference angle, then you add k times 180 degrees, where k must be an element of real numbers, and then already you know what is your reference angle. It's 60. So the solution in quadrant 1 is just 60 degrees. You add k times 180 degrees. That's your solution in quadrant 1. Then if I want to do in quadrant 2 where tan is positive, oh, I'm sorry, in quadrant 2, we just need 2 quadrants where tan is positive, the other one where tan is negative. So I've already did in quadrant 1, this is when tan is positive. Then I'm gonna go to quadrant, let me go to quadrant 3. This is where tan, it's also, okay, let me go to quadrant 2 instead. I think this makes sense. Quadrant 2. I'm just gonna move to quadrant 2. Okay, so I'm just gonna go to quadrant 2 because tan is negative in quadrant 2. So let's go to quadrant 2 and try to solve this. First quadrant, tan is positive, quadrant 2 tan is negative. Then in quadrant 2, you just take 180 degrees, you subtract your RA, then you add K times 180 degrees, where K must be an element of real number. So this will be 180, you minus your reference angle plus K times 180. Someone can choose to work maybe with quadrant 3 and 4 is fine. And then, oh, yeah. So when I look at this, I can say this is 120 plus K times 180 degrees. Then that will be your second solution. And guess what? You are done. You'll definitely get all the marks. Okay, I'm just gonna quickly move to the next question. This has to do with proving identities. So on this one, we are proving the identities. When you prove the identity, you're going to first look at the side that is more complicated, and I think I can work with the left hand side. So please, you say left hand side first, you rewrite the equation that is in left hand side, the sine of 2a plus the sine a, everything divided by the cos of 2a plus the cos a, then we add 1. So the reason we are doing this is to is for the marker to understand which side are we working on. So do you see the double angles? Yes. Then we need to change sine to a. We know that where the sine to a, we substitute 2, the sine of a times the cos a. Then I still have plus sine a. Everything good on top. Everything good on top. Okay. Then divide by, okay, so this one is the most complicated part. But if you get this one right, or if you understand my statement now that I'm about to say, you see this guy, the cos 2a, the identities for the cos 2a are the following. The first one, it's 1 minus 2, the sine squared a. The second one is 2, the cos squared a minus 1. And then the last one, that's like, is it cos? I think it starts with cos. That's cos squared x minus sine squared x. So how do we know when to use this 2? How do you know when to choose, which one to choose to use this 3? Okay, so please follow me now. You check what you have before or after that cos 2a. You check what you have. So if you have sine, you're gonna substitute this one. If you have cos, you're gonna substitute this one. And if you have the product of like something like this, cos x or maybe sine x times cos x, let me explain this properly. If this is, you're going to have something like this, you'll see maybe having like sine x that is multiplied by cos x. Wherever you see this product, these two things are multiplying, this is the best one to choose. So now, another thing, when you have 1 or -1, you choose the identity that will get rid of that 1 or -1. So in this case, we have +1. We need to choose the identity that will get rid of that one. Which one? The one that has -1, because we need to get rid of that one. So this is the correct identity to use. Okay, let me say this again. When you have 1 or -1, choose the identity that will get rid of that one. Okay, so let me just go back to this and substitute. So this will be 2 the cos. Okay, let's fix that. Okay, so this will change into, what is this? This will be 2 the cos squared a. We are minusing 1. Then we have plus cos a plus 1. So if you look at these two ones, they will cancel because one is positive, the other one is negative. So if I go back on top, can I take out a common factor on top? Yes. The top part, I'll have a common factor of, if you look at the top part, I have sine a and also sine a here. So I can just take out that sine A as a common factor. Remember, when you take out the common factor, you're going to replace it with what? With 1. So this will be, when I take out the sine A out, I'm left with 1 times cos A, which is just, I'm left with 2 cos A. Okay, then plus, we said we replace that with 1. Everything over, and then the 1 cancels. On bottom, I'll have 2 the cos squared A. Then we subtract, we are adding the cos A. Okay, everything good so far. Do we have a common factor on bottom? Yes, we do. We can definitely also take out the common factor. So on top, I still have sine A into 2 the cos A plus 1. And then the bottom part, you can see that we still have cos A again as a common factor. Not again, but the common factor is cos A. Then I'm left with 2 cos A plus 1. So look at this. These two guys, they cancel. And this leaves us with cos sine A over the cos A, which is just the tan A, which is what we are looking for. So I forgot to mention that the aim was to make sure that on top you have sine, get rid of everything on top so that you can only have sine, and get rid of everything on bottom so that you can only have cos. That was the aim of this question. Finally, the last question. This has to do with an if statement. Okay, so this one, this type of questions, they change every time. So they just check your understanding. Okay, so now they say if the sine theta is 2p. Okay, so what I'm gonna say, I know that 2p is over 1. So according to cut 2, what is sine? Sine is opposite, which is y, over hypotenuse. Okay, listen, they say if sine is this and you are given the cos of theta, which is p, remember it's all over 1, it's adjacent over hypotenuse. So you know what is your x, you know what is your r. Then they want us to prove that p is plus or minus root 5 over 5. So let's say you don't know how to solve the problem and you are in an exam. What should you do? You know what I'm going to do? Since I see that I'm given the opposite, the hypotenuse, I'm going to draw my right angle triangle. You're going to put this information on your right angle triangle. Look at this. Both the cos and sine, they have an angle of theta. This will be 90. So this tells you that this, it will be your adjacent, this will be your opposite, and this will be your hypotenuse. So adjacent is x, opposite is y, hypotenuse, that's r. So what I'm going to do is that I'm going to say that what is my y? That's 2p. You just have to substitute everything on this triangle. Your r, that's 1. Both of them, they have r of 1. And then your x, that's p. Then, now, let's find p. This is a right angle triangle. How can we find p? Theorem of Pythagoras, r squared is equal to x squared plus y squared. So you just have to substitute. This will be 1 squared. It's equal to your x, that's p squared, plus your y, that's 2p squared. So this is 1 is equal to p squared plus 2 to the power 2, that's 4, and then p squared. Okay, so now we are trying to solve for p. These are the like terms. You can add these two guys to get 5p squared, which is equal to 1. Divide both sides by that 5. And then p squared is 1 over 5. So now, when I square both sides, I'm looking for p. Look at what is p equals to. Plus or minus the root of 1 over 5. Then, can you see? You're going to ask yourself, is this answer same as this one? Is this the same? Nope. Those two are not the same. Then you're going to ask yourself, how can I do this to be the same? Let's try to simplify this further. Okay? Let's try to simplify this p further and see what we get. Let's try to simplify it further. So what we had is that we had p squared, which was 1 over 5. Then we square both sides. We set therefore p is plus or minus the root of 1 over 5. So remember, if I have root a over b, this can be written as root a over root b. So I can write this as plus or minus root 1, which is 1 over root 5. This is just like 1 over root 5, plus or minus. Okay, what's next? Okay, I need to bring the root 5 on top. So how can I do that? I can do that by rationalizing the denominator. Remember, we can rationalize the plus or minus root p by multiplying top and bottom by that root 5, because I need the 5 on my denominator. Then you row multiply this thing. 1 times root 5, that's root 5, plus or minus, the top part will be root 5 over, then you multiply these two, that's root 5 times root 5, which is 5, which gives us the answer that we are looking for. Guys, I know that I've been moving fast on this one. This was just a quick revision. So if you really enjoyed the lesson, please make sure that you join the family, subscribe to the channel, and I'm looking forward to see you guys on the next lesson. Thank you very much for watching.